and welcome to For the Love of Nature, a podcast where we tell you everything you need to know about nature and probably more than you wanted to know. I'm Laura.
And I'm Katy, and it is Independence Day here in America.
Yay!
And so for everybody else in our 75 other countries that listen to us, we're over here.
Day.
Yeah, just another day, but we're over here being hooligans
blowing
and blowing up stuff. And so that's what we're going to talk about is fireworks. And so we're going to be talking about fireworks, the history of fireworks, the science behind fireworks.
I was so excited to do this because that was one of my, in 8th grade, we had to take a career aptitude test, and mine was either a biologist, a stunt person, or a pyrotechnician.
Which all fit you so perfectly.
So
none of that is shocking.
Science and adrenaline junkie.
Yeah, none of that is shocking whatsoever.
I was like, finally, I can do the pyrotechnician part of this.
Yeah. I can let out my inner pyro. Woohoo! Finally. Alrighty, guys. So just like with a lot of these random things we do, Laura and I kind of divided it up. I'm going to go over the history of it. Laura's going to go into more of the science aspect of it. Yeah. So we're just going to go ahead. I don't think this is going to be a very super long episode, but again, it's another fun one for you guys.
Yeah, it'll be a little more in depth because of all the chemistry involved, I think. But I promise I won't bore you to death.
It's not super heavy chemistry. If it was super heavy chemistry, I'd have been like, nope, I'm out of here. Because that chemistry in college is torture.
The best part of chemistry. And I remember in high school, this part of chemistry where we got to burn stuff over the Bunsen burner and make the flames turn different colors.
Oh, yeah.
That was the best part.
That was pretty fun. Yeah. Alrighty, so I'm going to go ahead and go through, we don't have any nature news for you guys today, but let me go ahead and go through the history of fireworks because it really, really is a long history that goes back thousands of years.
I mean, can you just imagine the first person who discovered how to blow something up?
Oh, well, wait. So I did talk about that.
I can only imagine the power and
Well, and that's what it turned into. So the origin of fireworks, as most people know, can be traced back to ancient China, where they were accidentally discovered by Chinese alchemists searching for an elixir of immortality.
Of course. And then they blew themselves up.
Yeah, which is it's horribly hilarious that considering the components of fireworks, which is what Laura's going to go into, why they thought those pieces and parts would grant immortality. But I mean,
immorality?
Sorry. I said it and then I was like, wait a minute.
To be fair. It did kind of turn into that with some of the
right.
stuff.
It did. But I mean, it is science. You got to figure it out somehow. And I mean, I would say live and learn, but I don't think most of them would live and learn. And so.
That's horrible. We shouldn't do that. That's awful.
They're long gone. But that was around 2,000 plus years ago. These alchemists literally stumbled upon,
and maybe somebody even before then, but they blew up and never got to tell. Yeah,
nobody ever knew. Nobody ever knew.
Awful.
So this was the first documented case when they started mixing a mixture of sulfur, charcoal, saltpeter, which exploded when ignited. Initially, these early quote unquote fireworks were used for mystical purposes, as the loud noises and bright flashes were believed to scare away evil spirits or used for status, political influence. Kind of like a hey, I'm magic, you should listen to what I say kind of thing. I
mean, if you could blow something up and make awesome colors,
right?
It's pretty magical.
Yeah, right? I mean, can you imagine, 2,000 plus years ago, the lack of everything technology-wise, you would have no idea. Then all of a sudden, this guy comes, it's bang, and all this stuff, I would be,
absolutely,
this is amazing. Yeah. So the Chinese quickly recognized the entertainment value after a while of the value of fireworks and began using it for celebrations, religious ceremonies, and other festive occasions. Fireworks became an integral part of Chinese culture and tradition, and the Chinese were not only fascinated by the visual spectacle of fireworks, but also appreciated the artistry involved in their creation. So it wasn't like we're us here in America because of its explosives. It's not like there's not you go to a fireworks display and it's first everyone bring a firework that you've packed yourselves. You know what I mean? It's not,
goodness.
Yeah, right. Holy. It'd be so horrible.
I would absolutely never go to a fireworks display.
Right, ever.
Not in the area that I come from.
Yeah, the rednecks. I would love it. But they really like the artistry that went, the process of making it. And so from China, the knowledge of fireworks spread to other parts of the world, primarily through trade routes. So during the Middle Ages, fireworks gained popularity in Europe. They were used to celebrate special occasions such as royal weddings, religious festivals, and military victories. European pyrotechnicians began experimenting with different chemical compositions and techniques to create more and more elaborate displays. Again, Laura's going to go into more of like how that happened, but fireworks ended up becoming an integral part of royal festivals and entertainment across all of Europe. So during then the Renaissance period, like the 1300s to I think like just before the 1700s, marked a significant advancement in pyrotechnics. So Italian artists and scientists made really important contributions to the field during this time in general, including Vincenzo Galilei, which is the father of Galileo, the Galileo.
Okay.
So his dad
was a pyrotechnician.
Developed various types of fireworks, including aerial shells, ground-based fountains, and rockets. So it was like more of, you see the fireworks display. That's kind of what the Chinese did. Whereas these guys were like all the little ones you can buy at the convenience store, like the ground poppers and everything. Like that's what they kind of did. Fireworks became a prominent feature at royal courts, military displays, everything, because they're fireworks. I mean, why not? It's fun for everybody. Yeah. So as colonization expanded in the 17th and 18th century, fireworks made their way to the Americas. In the United States, fireworks gained popularity during the Revolutionary War. The founding fathers, including John Adams, Thomas Jefferson, advocated for celebrating Independence Day with fireworks. Hence, why now it's a cherished tradition that continues to this day. And so fireworks for here in America became synonymous with patriotism and the celebration of national identity for us. Let's blow stuff up like America.
Yeah,
America.
America and thing I can think
of.
It is.
Like it is.
Twinkies.
Yeah, right.
Which is also pretty synonymous with the summertime.
It is. So the 19th and 20th centuries brought significant, even bigger advancements in firework technology. Chemists discovered new compounds that produced vibrant colors when ignited, leading to the creation of multicolored display. And fireworks then evolved from simple, noise and light shows to intricate displays, and then further advancements in the development of electric igniters, time fuses, which all allowed for synchronization and choreographed fireworks shows, adding an additional and different type of artistry and precision to the displays and what the Chinese kind of like more of the process of making it, where now are like, let's see how we can just make this over the top. So in addition to their entertainment value, fireworks also have significant, like I said, cultural significance throughout history, which I've touched on at various points. They've been used to mark important religious festivals, such as Diwali in India and the Lunar New Year in many Asian countries. Fireworks are believed to bring good luck, ward off evil spirits, and symbolize new beginnings. In some cultures, fireworks are an integral part of wedding celebrations, symbolizing joy, prosperity, and the art of a new chapter in life. So the cultural then significance of the fireworks as it's continued to grow, spreading to various parts of the world. Different countries and cultures have adopted fireworks as part of their own traditions in their own way. Again, here in America, I know up north, it was always just 4th of July. Now down here in Texas, you want to talk about fireworks, like you get them at New Year's too. So it's Independence Day and New Year's.
Yeah, there's the occasional New Year's ones here, but not at all.
Oh my gosh. I think like the ground stuff is way worse here at New Year's than what it is in 4th of July. It is nuts. It's Texas. Go big or go home.
Blow it up.
And so like 4th of July, it's nuts, the number of fireworks. It literally goes off all night, fireworks. But then New Year's too, it's the same thing. And so it's both. So yeah, it's just crazy. But today fireworks are enjoyed worldwide, not only for their celebrations, but also the cultural events, sporting competitions, national holidays, all sorts of things. And the scale and complexity of fireworks displays have reached completely new heights, but with breathtaking pyrotechnic techniques featuring intricate designs, synchronized music, and just insane things of what they've proud of.
I can remember seeing new designs.
Absolutely!
What? How did they just make that smiley face?
Right. Yeah, it has gotten it has gotten really cool. So that's just a little bit of the history about it. And then we can go ahead and go into the science behind it all.
Yeah, and all fireworks have pretty much the same components, but I'm really going to be talking about the aerial displays. But like I said, they all pretty much have the same stuff. There's just sometimes more stuff in the aerial ones. But it's essentially, fireworks are just controlled explosions. So I wanted to talk about first the anatomy of a firework. Like, how is it built? What's the science behind it? Why does it go boom? So the first thing that you're going to need is a fuse, which is usually located at the base of the firework. Once it's ignited, it begins to burn, and it burns slowly, allowing plenty of time for you to run away before it blows up, hopefully. As the burning progresses along the fuse, heat is released, and this sustains the reaction for it to continue burning. So, it's just why stuff burns. The heat releases more, and then it just keeps burning.
Yeah.
Once it reaches the main charge, the chemical reaction results in a rapid release of energy. Hence, then helping it to ignite and further blow up. So there's a few different types of fuses, though, and Katy already kind of mentioned one or two of them. But the most common one is called the visco fuse. It's got a core of black powder, which I'll...
Not to be confused with Visco Girls. I think everyone's forgotten about by now, but...
I'll talk about, what's in black powder in a little bit. But the core of it's black powder, and it's wrapped in multiple layers of tissue paper or cotton. And the wrapping around it controls the burn rate of the fuse. There's the quick match fuse, which burns the fastest, and it usually connects multiple fireworks, allowing for synchronized ignition. It also has a black powder core, but instead it's wrapped in waterproof coating. There's the cannon fuse, which is thicker and slower burning. This is for large fireworks or pyrotechnic devices like signal flares and smoke bombs, and it's got a black powder core wrapped in cotton or hemp fabric, and it's very controlled, it has a controlled timing. You have plenty of time with the cannon fuse, thankfully.
Thankfully.
There's the safety fuse. This is most resistant to accidental ignition or moisture, and it's used in professional pyrotechnics or military applications. It's got a black powder core wrapped in textile fabrics, plastic coating, or both.
You would think everyone would just, default to the safety
one? Yeah.
Right? But we're America here. Yeah.
Right. Gotta live a little. And then, like Katy had mentioned a little bit ago, there's the electric ignition ones, which is not actually a fuse at all, but instead it's an electronic device that uses electric matches, which are basically just these tiny little things that ignite when an electric current passes through them. So that's all.
Which is neat. That's neat in itself. Just that. Yeah.
You
that's
press
pretty
a button
cool.
and
Yeah. What's that sound again?
Just this little firework.
Yeah.
So that's the fuse. Then there's the shell. That's all the rest of the body. And inside of it is a couple of different things. First is the propellant. This is the force that propels the firework into the air. It uses black powder or gunpowder, or a mixture. And like I said earlier, what is black powder? It is a mix of sulfur, charcoal, and potassium nitrate, which is saltpeter. So it is the exact same thing as those first people. Fireworks haven't actually changed that much because we're still using the exact same ingredients.
We just added stuff to it.
Exactly. So sulfur is the fuel in the combustion process. The charcoal is also fuel, but acts as a binding agent to allow it to burn more evenly. And the saltpeter serves as an oxidizer, which means that when it burns, it creates oxygen. So it fuels the fire because, of course, fire needs oxygen to burn. When the propellant is ignited, it triggers a process called deflagration, which is the rapid combustion process that travels through the mixture of the firework, releasing energy and lots of gas, aka it's the oxygen.
Yeah.
When this gas is rapidly expanding inside of the shell, it creates pressure and pushes out, propelling it upward. But then once the propellant, so that's the initial little off the ground. I'm going to keep giving great sound effects. So that's the little lift off the ground. Then the fuse lights up the lift charge, which is right above the propellant. It's essentially another type of propellant, but with a little more specific. It propels the firework even higher.
Oh, okay.
It's got...
so the one just gets it off the ground, kind of. The other one's the one that shoots it up
this is
super high.
More,
yeah.
Yeah. It's basically the extra boost.
Which makes sense because, depending on you have those huge fireworks and those need to go so much higher, but you know what I mean? But it allows you to do the different heights of everything.
Right, you'll even when you see a firework, you'll see it go up and you'll see it, and then
it keeps going up. You don't see the trail of it anymore, and then you see it keep going up.
Yes, the lift charge is lit. So it's more propellant, usually gunpowder though specifically, made to produce an extra powerful explosion to give it just a little bit higher. Then the explosive charge or the bursting charge, it's the same thing. That is what goes off after that. At the peak, it explodes. So the explosive charge consists of various chemicals to give desired colors and effects. But like all things that burn, just like the propellant, it has to have the same ingredients. It has to have a fuel, a binder, and an oxidizer. Okay? So the fuel gives it something to burn. The binder holds it all together, and the oxidizer produces that oxygen to keep it burning. And those can be lots of different chemicals. Oxidizers are things like potassium nitrate, potassium chlorate, potassium perchlorate. Fuel could be that charcoal, the sulfur, or other metal powders. And binders can be things like shellac, which is crazy.
That is crazy, yeah.
Stuff. Yeah. Polyvinyl alcohol, or just dextrin, which is a type of starch. Like you're just potatoing it together. And then the fourth thing in it is usually the colorants, which are metal salts. And by metal, like, it's not salt. It's like bits of metal. They just call them salts. And this is what gives the fireworks their colors. Sometimes these explosive charges can also have these things in them called pyrotechnic stars. And I had to look that up because I was like, what? Okay, so imagine that the shell is like a canister and it's full of your different, it's got your propellant, your lift charge, your bursting charge. Throughout that, there are these little pellets, and they can be shaped in different ways. They can be like circles or cylinders or some other things. They're like little tiny packages of their own stuff. Of the same thing.
Okay. Yeah.
So inside are pellets that are also made of a oxidizer, a fuel, and a binder.
Jeez.
Okay.
Yeah.
So like a firework in a firework. And those small pellet-like structures, depending on the way they're packed in there, determines usually color and the pattern. So like it's what makes a willow.
Shape. Okay.
A flower, right? Like the different shapes of the fireworks are dependent upon those pellets. And then finally, sometimes within the shell, there is timing and delay mechanisms. Typically, in aerial shells, like the ones that go off way high up in the air, there are 2 fuses, which is a time delay. So you got your first fuse that's lighting the propellant, like propellant goes up in the air. That lights the second fuse. That's burning as it's going higher until it reaches the peak and sets off that burst charge. So like the second fuse is setting the burst charge. So they've really timed it out. Like they've got the science down and timed just perfect. But, the science of, like, how the thing is made isn't really, of course, what makes them so cool. It's the awesome colors and sounds and shapes that they make.
Speaking of sounds, as you were talking about that, I looked up what makes the whistling in a firework. Are you going to talk about that at all?
I have the
whistling,
not the whistle.
Okay, so I found real quick that the whistle, because, we're talking about, again, it's essentially the same stuff, but it's a little bit of a mixture of something else. So fireworks, they owe their whistles to a mixture of organic compounds, but it's like gallic acid, sodium salicylate, potassium benzoate, and puric acid. So it adds in different acids. Yeah. And so again, these are mixed with oxidizers again and tightly packed into a tube. The small explosions caused by these compounds lead to oscillations in gases created by the burning mixture. And then this creates the standing wave in a tube which is producing that whistling effect.
That's cool. I love the screamers that you can buy. You just stick them on the they just yell.
Scream.
So, right. And then the other thing about, like Katie was just saying, there's the whistles and then there's the boom, and some of the, like, actually what I don't like, I don't mind the boom of colorful fireworks, but I don't like
the loud ones. Oh my gosh.
You feel it hit your chest. It's so loud.
It's just a bit much.
A bit much. There's not even, there's like a tiny flash, but it's really good for the sound. And at the end, they're always like, boom, 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 and you're looking for your whole body. Like,
well, down here in Fort Worth, they have, like, the last, I don't know, was it over COVID? I don't remember when we went down, but I stopped going because, like, they shortened the show. But we were there, and like they shorten it a lot shorter than normal, and then everything just went off all at once. And so it's so close. They do it really close, but they also do it really close to the ground, and then it goes up, not all that high. And so it's like layers. And so everybody around us was like, did that just like all blow up? Like, did that just blow up by accident? Yeah. No, they do it every year. And so everybody's just like, yeah, that's not cool, because it is terrifying. Yeah, it's terrifying because, yeah, those big booms and then everything's so close to the ground. No way. Yeah. Just no way.
So the boom is the result of the gases expanding at a rate faster than the speed of sound, which is resulting in a sonic boom. Which
is why it's too loud. Okay, if you have something that you're making, you're like, oh, it makes it because it's, faster than the speed of sound. Maybe that's a bit much, guys.
Yeah, it's intense. But the colors, this is what I always thought was the coolest part of fireworks, and the shape.
It is, yeah.
So colors are formed in two ways. And just in general, color in the universe is formed in two ways: luminescence and incandescence. So incandescence, think about a light bulb, an incandescent light bulb.
Mm-hmm.
That produces light because of the heat. So it's so hot that it starts to glow. And like the color changes the hotter the substance is. So like, it'll start off like, Diggles, come on, dude.
Diggles.
Right on the mic cord, so I can't. There. Okay. So the color depends on like the temperature. So like when it starts out, it's usually like an orange or a red. And then the hotter it gets, it starts to turn like more white.
Gotcha.
Or like an iron when you put it in the fire.
Yeah.
So that's incandescence. And so they can do that with fireworks. They can control temperature to a point. But that's not very common. Usually we're talking about luminescence. And that's chemical reactions that produce color. So the most common form. So that's those metal salts. Different metals burn different colors because of the different, like how fast the molecules are vibrating in that metal.
Yeah.
So here's your color chart for fireworks. Strontium is red. Calciums are orange. Sodiums are yellow. Coppers are blue. Bariums are green. Strontium plus copper is purple. And then aluminum, magnesium, or titanium is white.
So now you guys need to go back, listen to Laura say that again.
Yep.
Write all of it down, and then at your fireworks, and then tell everybody.
Barium fireworks.
Yeah, right?
I love the color of barium.
And just keep repeating it with every time one goes up. And just
I love it.
Yeah, right.
Yeah.
That would be amazing. That would actually make a pretty funny video too. That really would.
Do it. Yeah, take a video of it, please, and tag us. So yeah, that is like the science of fireworks, how they're made, how they produce their color, and how they produce their sound. But before we complete our episode, because this is a nature podcast, we do like to talk about the environment. And as amazing as I think fireworks are, I would love, like, when I die, send me out with fireworks.
Noted.
But
you're the carbon to the firework now.
Oh my gosh, turn me into a firework. Yes.
That's what I meant. That's where I thought you were going.
Absolutely. That's now.
Okay.
Yeah.
I'll talk to Justin and we'll arrange it.
It just has to be over holy ground since I'm Catholic. So shoot me over a Catholic graveyard. Over a graveyard.
Okay.
Okay. So fireworks are awesome, but they are definitely not the most eco-friendly thing, sadly enough. So I'm going to end a little bit on a downer, but I'm going to twist it at the end with a positive so we're not all depressed today. But fireworks, of course, produce smoke, particulate matter from the explosion, and gases. And all of these can have a negative impact on air, soil, and water quality.
That's the one thing. Like, whenever we were kids growing up and we would go to a fireworks display and there's all those people that try to get like as close as possible. And my dad was always like, nope. And we would scoot back.
I can feel the ash falling on me. Too close.
Too close. Yeah. And some people are like, they're like, I'm like, nope, too close.
You can feel it.
Too close to me. Yeah, too close.
You're not feeling it. But so here's some stats. So some of the oxidizers that they use in fireworks are known as perchlorates, which according to the Environmental Protection Agency are known to affect the thyroid's ability to produce hormones. So not good. And like, how bad is this issue of perchlorates? Well, they're heavy metals. And it's never good to have heavy metals. Basically anywhere in nature. You hit heavy metal, you avoid that place. You don't drink the water. You don't use the soil. You don't breathe the air.
As Americans flock to the area.
Yeah.
Heavy metals.
The only heavy metal that's good is music. And even then, depends.
Yeah.
So heavy metals produce, short-term effects are like vomiting, diarrhea, asthma. But longer things are kidney.
Sorry, I just
from heavy metal music.
Well, that, but I also just like, how immediate are these effects? Because like, are you gonna
use fireworks and just
blowing out? You can watch
an asthma attack as stuff is coming out both ends.
It is
horrible.
That's what I'm saying. That'd be so bad, but also so funny.
That's awful. Heavy metal toxicity. And then the longer effects are kidney disease, cardiotoxic effects, and of course, cancer. There's nothing like Independence Day.
like cancer. God.
I'm laughing. It's terrible. Okay. How bad?
Well, no, I'm laughing because it's like this, like that we haven't found another way. Like we've been making fireworks essentially the same way.
2,000 years.
Yeah, 2,000 plus years, the same freaking way. Like
the thing. All of our listeners right now, especially us Americans, are like, yeah, but Laura, how bad can this be? Like we only do fireworks once a year, and like, come on, how bad can it be? Pretty freaking bad, guys. I'm really sorry, and this was a real bummer to read, but. I'm really aware of the air quality index lately because of this whole like Canadian wildfire. The smoke all came out where I live. So everybody's reading like the air quality index. There is such a thing as an air quality index. It goes from 0 to 500. 400 and above is severe. Do not be in that air. Okay.
Well, yeah. Look at New York City recently, how bad that was and everything. Yeah.
It's a city. Yeah. You're like in a fire.
Yeah.
Well, some scientists have taken tests of the air around fireworks displays, and particularly in Delhi, in India, during Diwali, which is, of course, the Festival of Lights, and they're sending off tons of fireworks.
Everything, yeah.
The air quality in Delhi, in some parts of the city, was 500. Like, you shouldn't be breathing. Like, toxic air.
And that's too, because that's like everybody shooting stuff off, like
at one spot.
But it's also like, we have laws and restrictions. I don't know to talk about that here, but a lot of other countries don't have those restrictions. So it's just everybody shooting off everything whenever, wherever they want kind of thing.
And then even places that are better. So, in London, which is this is in India, this is over in England. In London, some levels of heavy metals in the air after a fireworks display were anywhere from 6 to 120 times normal within the hour.
Yeah.
120 times normal.
But you're exploding that stuff. You know what I mean?
You're exploding into the air. So what it does is it creates small bursts of ozone. It increases nitric oxide, sulfur oxide, which both create acid rain and are climate change gases. And heavy metals from these fireworks can travel 62 miles downwind over 2 days. So we're aerosolizing heavy metals.
and celebrating it.
as we breathe it in. Yeah. It's pretty messed up.
And I know for a while, and they still have these, but they tried to replace fireworks displays, and they still kind of are with those drone shows, which have kind of fallen flat on their faces. Because it's a whole other different
explosion.
Yeah, it's something totally different. Like, I think they're neat, but it's something totally different.
Yeah.
That at least for Americans,
that's not fully sensory.
No, and that's what it is, and I don't think it's going to replace fireworks anytime soon.
And the other thing that's, a lot of times we do fireworks displays over water because it helps with things catching on fire. But unfortunately, then all those heavy metals fall right into the water.
Going into the water.
Into our water, guys. So this might not be, okay, but it's not so bad in rural areas because around these parts, we're only doing it once a year. Okay?
Yeah.
But there are some places in our country, and I'm looking at you, Disney.
All the time.
Disney parks have on average 230 fireworks display shows per year.
Okay, if anybody has not seen Disney fireworks displays, it's fantastic. The same company that does the Disney fireworks displays does them is out of Pittsburgh. And so it is, so same thing. I've seen them at Disney, seen them like the ones in Pittsburgh and stuff. Amazing.
Oh, yeah.
But it is a lot. It is a lot of fireworks.
They use 90,000 pounds of fireworks per year.
Jeez.
So, Disney, you're ruining the atmosphere. You're poisoning Florida. I love you.
Even more.
But, yeah.
Yeah.
Like, poor Florida. It never had a chance.
No.
But on the positive side, besides those of us who are living in rural areas and are pretty good about our air, they are developing what's called cleaner fireworks. Will this catch on? Probably not, because Americans are Americans.
Yeah, we're still using lead ammo.
Right.
I mean, like...
But there is an alternative option if anybody cares, and it's using compressed air instead of some of those gases, and it doesn't use any perchlorates as oxidizers. So no metals that are causing thyroid problems.
Protect your thyroids, folks.
Public service announcement. Protect your thyroids, folks. So yeah, cleaner fireworks. Promote cleaner fireworks is what we should be doing. Absolutely blow things up, but do it cleaner.
Right. For the sake of your thyroid.
And then, I mean, that's just air and water and stuff quality. But the other problem with fireworks, it's probably not as imminent of a danger, but it is crazy noise pollution for local wildlife and pets. A lot of people's pets.
And my dogs don't like it. I
always imagine the poor birds. Like,
oh my gosh.
Can you even imagine? Like, you're in your little nest trying to go to sleep. Your whole tree shakes. It will be, I just can't even imagine. The poor things.
Yeah.
And then the noise can be severely triggering to those people that have PTSD.
Yeah.
So be aware, if you have friends, family, or neighbors that might be suffering from PTSD, like, be aware, be cognizant. Maybe don't set up giant fireworks next to your neighbors.
Or heck, just be considerate overall, because some people have to work the next day or they have a baby. I wanted to freaking murder people last year for setting off fireworks because Alora could have woken up.
Oh my gosh. Yeah, whenever Luke was little, I was like, oh my gosh, can't. I have seen, whenever we first moved down to Little Rock, there was a kid, and I say kid because he was a kid, and we always said he was like Bad News Brian. Like, no matter where this poor kid went, like, bad things always happened to him. And so, Air Force, and so hundreds of dollars. It was definitely thousands of dollars for like ground fireworks and stuff. We go off to this spot because a lot of places, they are, first of all, let me just say, fireworks should always be handled with caution and used only in designated areas, whether large or small.
Yeah, they can burn 1,800 degrees.
Yeah, so hot. And it's important to follow any local laws and guidelines to ensure both personal safety and safety of others. I know where I live, it is, you're not allowed to set off, but it's mostly because it's,
some places you can't even buy them.
Yeah. We can buy them, but most counties down here, you can't set them off just because everything's so freaking dry because it's Texas in the summer. But yeah, so they can be very dangerous if mishandled. And one story, for instance, is this, again, I say a kid because he was a kid, but thousands of dollars worth of fireworks. Everybody's being very responsible. But at the same time, it's a bunch of dudes. And so I'm like, oh my gosh. And my wilderness first aid responder kicked in because I'm my spidey sense. I was like, something's going to go bad. So here goes this kid, Bad News Brian. He goes out to set off something in a canister and it wasn't going off.
Ugh.
And what does he do?
What an idiot.
Walks out towards it and immediately, we were all like, no, boom, went off. That kid,
he's
singed his eyebrows off, singed his eyelashes. Meanwhile, we're this is Arkansas, the middle of freaking nowhere at this little lake. There were a bunch of other people. You all go there for the fireworks display that's there, but then everybody's setting off stuff, ahead of time and stuff. And that's what we were doing. But we had just moved there. And so we have to take this kid. We have to find a hospital. They put in these little contacts into his eyes that have tubes running from them to wash his eyes out because that was so bad. That kid is lucky that he didn't lose fingers or his eyesight.
I actually have a relative that lost 2 fingers to an M80. It's no joke.
Yeah, I don't mess with them, and again, that's just overcautious law following Katy.
Yeah.
But I don't I enjoy it. It's fun, but at the same time, I
like sparklers.
Yeah.
The little stuff.
Yeah. I'll do the fun stuff that I know is going to be safe. And if anything is going to be, and I inspect everything. I am that person that if I'm going to shoot something off, I'm looking at the canister to make sure everything's still. Because, you can't see inside of it, but still making sure the outside container is still there. Because I've opened up those fireworks packets and there's been something that's ripped. And I've seen other people that are like, oh yeah, let's shoot it off. I'm like, no, if it is punctured. Yeah, if something is punctured or something, then it's not going to go off right, and you can't rely on it. So just absolutely, as fun as entertaining it is, please, please, please be careful and responsible as you guys are going out and celebrating today.
Definitely. Definitely, definitely, definitely.
That's fireworks, guys. All right, guys, make sure you reach out to us on Twitter and go ahead and follow us, chat with us on there. Send us, if you do an annoying fireworks commentary of all the chemicals, please send that to us too. We would love to see it.
Yes, yes.
Yeah.
Please send it our way. Oh my gosh. I would love to hear that. All right, everyone. Hopefully you know a little bit more than you used to. Your curiosity has been piqued, and maybe you care just a little bit more. Tune in next week, everybody.
Bye.